Okay, so far with our polynomials, we've been finding all the zeros, but now we're going to come across some imaginary or complex roots. So not only do we need to find all of the real roots, we have to, good morning, we have to find the imaginary. Ooh, Molly, you get to leave at 9:50. Lucky. There you go. Okay, so here we go. There's just two parts. It's pretty short, but it's very meaty. All right, we're going to find the zeros. So you know how to find the zeros of a polynomial a number of different ways. For example, the first way that I always learned how to find the zeros was to factor, right? If you get it in the polynomial in its factored form, you can see exactly what the zeros are of the polynomial. So you want to factor. You can also graph. When you graph a polynomial to see the zeros, they're the X-intercepts, okay? Now, that will only show you the real zeros. It will not show you the complex or imaginary zeros, okay? Another way to find the zeros, if it's a quadratic, you can use the quadratic formula. Or if you know a possible zero and you test it, you can do synthetic division, which is what your quiz is going to be a lot on. Like given some zeros, do some synthetic division to get it down. Okay, so let's go ahead and let's get into it. Let's get one. Here we go. We are going to have a polynomial f of x equals x to the 5th plus x cubed plus 2x squared minus 12x plus 8. Minus 12x plus 8. Wow, that's a big old polynomial, isn't it? All right, so let's talk about this polynomial real quick. What we're going to do is we're going to find all the zeros. All the zeros of the polynomial, okay? And how many will we find? 5. We're going to find 5. The book says at most 5 because they don't count multiplicities as 2, but I always count them as a double, so it happened twice. So what you want to do is your first step is you want to graph this on your calculator. Okay? So let's go ahead and plug that in. Oops. I can do it if you don't want to get your calculator out, that's okay. But yeah, if you want to do it too. And what we're looking for is we want to find the X-intercepts, because that's going to tell us the real zeros of this polynomial. So I graph it, and it looks like this. Okay, so what this tells me here, this is what my graph looks like. Goes through -2, goes up higher than my graph does, which is fine, and it comes down and, oopsie, brushes +1 right here, sorry, and goes back up. Okay? All right, so that's what it should look like in a way. It's a degree 5, it's an odd, it has a positive leading coefficient, and so it should start down and go up, and then it goes through a couple of times, okay? So let's talk about what the zeros are. From the graph, we can already tell some zeros. The zeros that I find are -2 and +1. +1 is special, though. What can you tell me about +1? Yes?
Does it have a multiplicity of more than 1?
Perfect. It does. It has a multiplicity of more than 1 there. And so what is the multiplicity there? 2. It looks like a parabola. So it has a multiplicity of 2. Okay? So basically what you have found by graphing is you have found 3 of the 5. Okay? This one happened twice, so I count it twice. So I found 3 of them, and now I need to find the other 2. So let's go ahead and take the ones that we have, and let's do synthetic division to divide them out of there, to get them out of the way so we can find out the rest of them. So synthetic division, don't forget, we're going to have 1, and then what's the next number? 0. Yes, don't forget to fill in any blanks. That's a really good, helpful hint for today's quiz too. 1, 0, 1, 2, -12, and 8. Now we know -2 is a 0, so I'm expecting my remainder at the very end to be 0. If it's not, we did it wrong. Okay? All right, so bring the 1 down. 1 times -2 is -2. Add the column, -2, 4, 5, -10, -8, 16, 4, -8, 0. Woo! My arithmetic skills are good today. Sorry. Really good. Alrighty, so now what we've done is we've taken this x to the 5th polynomial down to an x to the 4th. And let's go ahead and divide it again. And let's use a 0 of 1. Okay, so 1 comes down. 1 times 1 is 1. Negative 1. Negative 1 times 1 is negative 1. 4, positive 4, negative 4, negative 4, and 0. Yeah?
Where'd you get the 1 from?
Ooh, it's right here. It's that one that had the multiplicity.
Oh.
Yep. So our zeros up here are 1, 1, and negative 2.
Okay.
And so you can divide your polynomial any order. It doesn't matter. I just picked now negative 2 first. Now I did 1, and guess what I'm going to do now? 1 again. Yes. You could stop there technically. It's a cubic, and it has 4 terms, and you could actually factor it by grouping. But why not just divide all the ones that we have? So 1 happened twice, we can use it twice. So bring down the 1, 1, 0, 0, 4, 4, 0. See, as long as every single time you get a remainder of 0, you're good. Now what you end up with is, so we divided this 5th degree polynomial 3 times to get it down to a quadratic. So we have x squared, there's a 0x, which we don't need, and plus 4. And this is equal to 0. And so we're going to solve for this. So solve by subtracting 4 to the other side. And then take the plus and minus square root. And what is the plus and minus square root of negative 4? 2i. 2i. Remember that? Okay, so what was the question? How did all this work? What were they asking for? It says find all the zeros. So the zeros are plus and minus 2i, 2, and 1 with a multiplicity of 2. So there you go. We found all 5.
Negative 2.
Whoopsie a woo woo. Thank you. Negative 2. Cool. Yes? Isn't that fun? It's good, clean fun. Really, we just worked our way all the way down. So exciting. Okay, now, number 2. For number 2, we are going to factor. Okay? And you guys are really good at factoring. Okay? We're going to factor over 3 different number systems. Okay? We are first going to factor over the rational numbers. Now, in order to factor over the rational numbers, you need to know what rational numbers are. So rational numbers are all the numbers you know except for the really ugly ones like pi and rad2 and those kinds of numbers, okay? So we're going to factor over the rational numbers, and then we're going to factor over a different set of numbers. We'll go from there. So here we go. Here's our polynomial that we're factoring. X to the 4th minus x squared minus 20. All right, looks kind of scary at first because of the x to the 4th, but you're just going to factor it like a quadratic. But instead of, x times x, it's going to be x squared times x squared. And then you can use star method, or just what times what's negative 20 adds up to negative 1 is a negative 5 and a positive 4. Now, in algebra 2, we would stop right there. Did I do it right? Yes, okay. In algebra 2, we'd stop right there because we were not allowed to factor anything that was not the difference of 2 perfect squares. So this one is the difference, but 5 is not a perfect square. This one is a perfect square, but it's not a difference. So then we stop. Okay, now we're going to keep going. We're now going to factor over the real numbers. The real numbers. Now, real numbers include rational and irrational, but not imaginary. Okay, so we're going to take this x squared minus 5, and we can factor that. Do you know how we can factor that? X plus rad 5 and x minus rad 5. And this does not factor over the reals. You see that? Now, if you get stuck on that, what you can do is you can take this and go x squared minus 5, set it equal to 0, and solve. And so you get plus or minus rad 5, which in its factors is plus rad 5 and minus rad 5. Okay? But if I were to solve this one over here, this x squared plus 4 equals 0, we just solved this. We get plus or minus 2i. That is not going to be factored over the real numbers. Okay. And then finally, we're going to factor this over the complex numbers. And so to factor over the complex numbers, we still have x plus rad 5 and x minus rad 5. And then I'm going to take this x squared plus 4, and I'm going to write it into its two factors, which would be x plus 2i and x minus 2i. Okay? Crazy, huh? So back, like I said, we stopped here at Algebra 2. This is where we stopped. That's all we could factor. Now they asked us to factor over the real numbers and then over all the numbers, everything. And so you get this fourth degree polynomial has 4 factors. It has 4 zeros. And you just write them all out in their factored form.
Do you have to like do it all separately? Or can you just
I think it'll be ABC.
Oh, okay.
Yeah, I think they ask you to do it separately.
Okay.
Yep. Okay, now let's talk about complex zeros real quick. Okay. So we know that if the degree of your polynomial is n, then you're going to have n zeros or n factors, n roots, whatever you want to call them. Okay. Sometimes you'll find them on the x-axis, sometimes you won't. Okay. The other thing is that the complex numbers that are zeros, the complex numbers, what happens is they always come in pairs. Okay? Always. So not only are they pairs, but they are also conjugates. Do you remember what conjugates were? Yeah? Do you remember? So like, for example, if I had 2 plus I, what's the conjugate of 2 plus I? 2 minus I, yeah. Okay? Or if I had negative 3 minus 5I, then my conjugate would be negative 3 plus 5I. So only the middle sign changes on conjugates. So if 2 plus I was a 0, then 2 minus I has to be a 0 too. They always go in pairs. It's kind of like girls going to the bathroom, you know? Always going in pairs. All right. There you go. So knowing that, this is what we're going to do. Part B. 2 more examples left. You're halfway done. Oh, see, we're only at 12 minutes. That's really good. All right. So for this one, we are going to be given the zeros. So last one, part A, was we have to find all the zeros, right? We found the zeros by factoring, by synthetic division. Now we're going to be given the zeros, and we have to find the polynomial that goes with that. So number 3. Let's say that our zeros are given to us as 1 and plus and minus 5i. Okay? They always come in pairs. If they only give you 5i, you have to assume that negative 5i is there. Okay? You have to. All right, we're going to find a polynomial in standard form. That means we've got to factor it all out, or FOIL it all out. Find a polynomial in standard form. Okay, if you know the zeros of your polynomial, then you know the factors that go with that. So I have f of x equals, my factors would be x minus 1. Then I have plus 5i and minus 5i. So x minus 5i and x plus 5i. Okay? So right now, this doesn't even look like a polynomial. Have you ever seen a polynomial with imaginary numbers in it? No. They're hidden in there. So this one, what we're going to do is we've got to FOIL this whole thing out. So what you want to do is you want to first FOIL these 2 out. Okay? You always want to take the complex parts and FOIL the conjugates. So when you FOIL this, you get x times x is x squared. Do you see what's going to happen outside, inside? Do we need to write it? We can. They cancel. Yes, they will always cancel. You get 5xi and negative 5xi. Those will always cancel out. If you want to skip that step, that's fine. And then we get minus 25i squared. All right, so let's go ahead and simplify this. Let's fix it up. I've got x squared. The 5xi and the negative 5xi cancel. And then what is negative 25i squared? Yes, it's positive 25. Remember, I squared is negative 1. Negative 1 times negative 25. And then we're going to take that and multiply it times x minus 1. And you would think, you see how these right here, this x squared plus 25, this is how it factors. X plus 5i and x minus 5i. All right, FOIL it out. Here we go. X times x squared is x cubed. Outside gives me 25x. Inside is negative x squared. Dang it, I should have done it the other way. It's all right. And then finally, standard form would be descending order of exponents. Yay. So f of x equals, and that would be our polynomial. This one's factorable. Do you see how it's factorable? By grouping? Did you ever look at that and go, oh, we can group that, and then you factor out x squared, you factor out 25, all that stuff. Anyways, okay, and you would just get back to your factors. Let's do the last one, which is the worst one ever. It's my favorite problem of the whole school year. People get real mad at me on this one. Here we go. That's really what my job's all about, just making people mad. Okay, here we go. Without a calculator, find all the zeros. Find the zeros of f of x equals x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. Okay, so this whole section is given the zeros. And why we're finding the zeros? Well, because you are given that 1 plus 3i is a 0. Okay. Now, you could, back in the day, take all of your factors of 60, which are quite a bit, over your factors of 1, which is just 1, and test them all in here. No, we're not going to do that. All right, we are given that 1 plus 3i is a 0. So, what do we know right away? Perfect, yes. 1 minus 3i is also a 0. Great. Now, what we just did right there was we have half of them. We just have to find the other two. No big deal. Okay, there's a couple of different ways you can do this. One, you can put these into factors, FOIL them out, and do long division. I've done that before. It's not my favorite thing to do. I'm going to use synthetic division instead, okay? People who disagree with me yesterday, Bobby, for example, he wanted to do it the other way. I was fine with that. All right, but I'm going to do synthetic division. I'm going to take 1 plus 3i, which is a 0, and I'm going to do long division. And give yourself a bunch of room. Yeah?
How do you do synthetic division with something like that?
Yes, I'm going to show you. It's insane. Yeah, it's really not fun. Here we go. So we're going to have 1, negative 3. Spread it out. You're going to need some room here. 6, 2, and negative 60. And we're expecting to get 0 at the end. Okay? Hoping. Okay. So here we go. Let's do it. Bring down the 1. We're going to multiply 1 times 1 plus 3i. And we get 1 plus 3i. I'm going to add the columns. Okay? So negative 3 and 1 go together. Give us negative 2 plus 3i. Now here's where the groans happen. Because you realize you're going to have to FOIL. Yes. So I'm going to go over here, and I'm going to take 1 plus 3i and FOIL it to negative 2 plus 3i. Okay? Yes, and that's where you're like, ugh, right? Totally. All right, negative 2. Outside gives me 3i, and inside gives me negative 6i. Can you combine those at one time, or you need to write it all out? Either way, it doesn't matter. So 3 minus 6, that gives me negative 3i. And then my last term is 9i squared. Okay, so I should get negative 9. Negative 2 and negative 9 give me negative 11 minus 3i. I didn't give myself enough room. Okay, do it again. Add those together. So you add 6 and negative 11, you get negative 5 minus 3i. We got to FOIL again. I know, it's terrible. It's terribly good. 1 plus 3i, negative 5 minus 3i. Okay, so multiply it. We get negative 5. Outside I get negative 3i. Inside I get negative 15i. That gives me negative 18i. and then minus 9i squared. Now negative 9i squared is positive 9. 9 and negative 5 make 4. So now I have 4 minus 18i. Should have spread it out a little bit. Okay, add it up. 6 plus 18i. Now here's where, or it's minus, huh? Whoopsie woo-woos. That would be really bad if I messed up right there. 6 minus 18i, sorry. Here's where you can either trust yourself or you need to FOIL one more time. Because when you FOIL 6 minus 18i and 1 plus 3i, what are you going to get? Positive 60. You should. Should we test it, make sure it works? No? You trust yourself? 6 minus 18i. You get 6. Inside is 18i. Outside is negative 18i. So those will cancel out, giving me negative 54i squared. Oh, what does that equal? 60. And then we get 0. Yay! Okay, we only have to do it one more time. So now we're going to take that, and we're going to do 1 minus 3i. Okay, except something great's going to happen here. You're not going to FOIL, not one time. Okay, I'll show you. When you bring down the 1 and you multiply by 1 minus 3i, look what happens. Oh, all the i's are dropping out. So you get negative 2 plus 1 is negative 1. Multiply again. You get negative 1 plus 3i. The i's dropped out again, leaving you with negative 6. Multiply negative 6 times 1 minus 3i. You get negative 6 plus 18i, and there's our 0 again. Okay, what does that give us? Well, that gives us a quadratic that is factorable. X squared minus x minus 6. Set that equal to 0 and solve. Now you might have to do quadratic formula at this point. I try to make it so it's factorable, so we don't have to do quadratic formula. What times what's negative 6 adds up to negative 1? Good. Negative 3 and positive 2. So my zeros are 3 and negative 2 from there. And so let's go back to the very beginning where it says find all the zeros. So we're done. All the zeros are 3, negative 2, and 1 plus or minus 3i. There you go. Right? Wasn't that so good? There's a couple other ways to do that. I enjoy that way. That's my favorite way to do it. Just to really, like, so you hate me even more. I don't know. Something like that.